Okay, now you understand the lecture will be too many. You cannot get the time to reading everything. But what I want you to get through the left zone. You can do it by yourself, no problem. That means you're okay. Okay, on this one, okay, what? Okay, you already know. Okay, this is a sideway, and this is a time domain. That means the signal vary with the time. Okay, when they start and they repeat it, that we call one cycle. Okay, and we already talking about that. And another one, if you're looking on also the signal. However, the domain will be distant. Okay, and that will be one wavelength. That for RF, that means talking about the signal transmitted over the air. If we get the time, we go to RF, radio frequency, then you can understand more. Okay? On this one, they're talking about sine wave. Okay? And you say that will be one cycle. That means one T. And the voltage, okay, this signal display on oscilloscope is a zero here. That is a V peak, 3 volt, 1 volt per division. And peak to peak will be double. Okay, that means 6 volt. However, we have to deal with the VRMS. And VRMS equal 0.707 times V peak. That given to you. VRMS equal 2.12 volt. The average they get a formula. We don't care. We're not using that. We're using V peak, V peak to peak, and VIMS. The period, 7 milliseconds. That means from here to here, 1 millisecond. And frequency 1 over T. F equal 1 over millisecond. That's what you get frequency. Okay? Next week you start working on semiconductor circuitry. You have to using the oscilloscope generator. Okay? That I talk to the lab instructor tomorrow first thing. They have to teach you the oscilloscope and also the generator. Okay? Now, we're talking about diode. Hey, man, I don't know how. Okay, anyway. Did a physical, okay? Basically, a diode just a PN, okay? P here, N here on the semiconductor. N contain negative, P positive, okay? And this is the junction between P and N. Basically, that is semiconductor diode, okay? So this is simple symbol for the diode. One side, P side anode, and another side, cathode. Okay. Voltage V from A to C. Okay. That's what they call a VD. Diode voltage. VAC. That means VA minus VC. That's what they're talking about. Voltage across diode. Diode normally permit electron current flow only one direction. Okay, so when this PN junction, okay, smaller, and you can get the current flowing, okay, from P side to N side. Now, you can see they draw the current flow this way. So basically, that means they're talking about electronic. Current. That means they're talking about electron moving. However, we deal with the conventional current. So current will be flow this way. I. Okay? That means the current flowing from positive to negative. Okay? And the current flowing only one way. Either they flowing from A to C. They cannot going back. Okay? Cannot backward. So for the diode, they allow current only flowing from positive anode to cathode. I'm talking about conventional current. Okay. For the diode, first thing, ideal. Never happened. Okay. However, you need to know. Ideal permit current flow from anode to cathode, diode on or forward bias. Either way, you can say diode on. That means current flowing anode to cathode. Okay. That is forward bias. And for the ideal diode, VD equal 0. That means the voltage across the diode here they call it VD. For ideal, VD equal 0. Okay. Then the diode can be either open that's what we call a reverse bias. They're telling you one thing, no current can flowing from A to C. That will be A. That will be C. Okay? That will be diode off, and that will be open. No current flowing A to C. Okay? And resistance from A to C will be infinity. Oh, you understand that open circuitry. Okay? And when the current can be flowed, that's what they look like. They say forward bias. So current can be flowing from A to C. Now we go into practical diode. Diode, same thing. Look like here. Anode, cathode. Okay. And now, when they say reverse bias, that means diode open. You see that? open here. Okay. And this is a 0.7 volt for silicon diode. Basically depend on what the material they build the diode. Okay. And this is a 4-watt bias. That means diode on. So they connect it. And this is a 0.7 volt. Okay, now we'll see. For this circuitry, you get 10 volt positive, and you get a diode. So how do we know the diode on or off? That means the conducting or not. Okay? In order to know, make sure the voltage here, okay, from Vout to the ground must be equal or higher than 0.7 volt for silicon diode. Let's see what they do. Calculate given VD equal 0.7 volt. Okay. Now, if you're looking into the circuitry, how do we know the diode on or off? Who knows? Let me know. How do we know diode on or off? One thing I can tell you. If you say diode on, that's telling you the V here, V out, have to be equal or higher than 0.7 volt
Yeah.
to turn on diode.
And Mr. Pham, is this where you want us to take the diode out and then measure,
The current.
put the black lead on ground, so the red lead where V out is at, and then you'll measure 10 volts. So
Okay,
then if you get,
okay, you know. Okay.
Yeah, you measure current, right?
In order to get the V out, to say what V out supposed to be, you have to suppose no diode. That means we cannot get any diode connection. I don't know how come this point here before they open, now they not, before they working, now they not working. I don't know why. If you know, let me know.
Are you talking about the colors?
Yeah, the red,
Hmm.
only thing the people working on iPad, maybe they know. I cannot understand.
but the main thing is you want to take the diode out and then measure, and you should get 10 volts at V out. And since you have 10 volts there, the 10 volts is greater than the 0.7, so the diode is forward biased.
Okay, you know, you're talking almost correction. Now I telling you, in order to know what the V out, you suppose no diode connect here. No
And
diode.
you
What V out?
subtract the diode from the 10 volts and you divide it by the resistance.
No. My question is, you remove diode.
Yeah.
Supposed to be no diode.
Uh,
Question A, what V out?
If you remove the diode and you measure, you'll get 10 volts.
No, I don't measure. I just
What?
asking what V out.
is 10 volts.
10 volt. Correct.
Right.
That's what I want. If you remove diode, that means an open circuit, right?
Right.
Mhm.
No current flow here. That's why you get 10 volt, okay? And 10 volt higher than 0.7 volt. So now you say diode on. Okay. And when we say diode on, you don't care about symbol anymore. You have to substitute by the battery. What the battery voltage?
0.7.
0.7. So now you draw positive, negative, plus, minus 0.7. So what we are now equal?
9.3.
No, V out is equal to 0.7.
Exactly.
Oh, oh, I'm sorry. I'm sorry.
The thing is, V out will be measured from V out here to the ground and the battery 0.7. Okay. So that's why you get VD 0.7. So the first question, diode on or off?
On.
On. V out equal
0.7. Current
current I.
9.3. How is
Current.
9.3
No,
mA?
9.3, right?
Yes.
9.3 what?
9.3 mA.
Milliamp.
Yes.
You take the 10 volt minus 0.7
Yes.
divide 1K.
Okay.
That's what you get the I. Okay, 10 minus 0. Divide 1K.
Yep.
9.3 milliamp. And V across R.
9.3.
9.3. You take 10 minus 0.7, right?
Mm-hmm.
Okay, that is the first problem. You get any question? Let me know. Okay, we go to the next, number 2. First thing, without the diode, what we out?
Be out 5 volts.
No diode. We out. Okay? That means I telling you, if you want V out, you supposed to be remove that diode. They're telling you V out equal to the power supply, V by 5 volt. And if you get a 5 volt V out, question the diode on or off? The diode will be on or off.
Off.
On.
You get 5 volt here. If no diode, you get 5 volt here. You can see anode, cathode here.
Mhm.
Anode is round. So diode must be
Off.
off. Must be off. In order for the diode on, anode have to be higher than cathode 0.7 volt for silicon diode. Okay, diode off. What VL equal?
And Mr. Pham got a question.
Your head.
Where you got the 5 volts at V out, is that a -5 or a +5?
You can see right here.
It's positive.
The reason why I say that, because you said the anode is at ground and it's 0, and well, the V out is 5.
So the thing is you understand is, before you want to say the diode on or off, you suppose no diode connection. No diode connection here. Then VL will be equal 5 volt. Correct?
Right.
Okay, now when you see the diode connect, you get a 5 volt here, round here. Then you know the diode will be off. For the diode to be on, anode A have to be higher than collector, for C,
Mm.
0.7.
Because 0 is higher than 5 volts.
Yeah. Zero.
Yeah, 0 in the anode, 5 volt cathode, diode must be off. And V out equal 5 volt. Current I but current equal
Zero.
0. The thing is current cannot flow it. Diode off, that means they out open. So no current flow. And the last one, what the voltage across R, V in here.
Zero.
0. No current. So that's why voltage across resistor will be 0. Okay, if you get any question, go ahead and ask, okay? You have to really understand it.
And the way you could check that, right, is to do VD equals VA minus VC. Do the math, right? And then that would equal 0 minus 5 equals 0, right?
0 minus 5 equal minus 5.
Right.
However, by looking into anode, and the cathode, that means A and C.
Right.
The diode, then
It's
you
off.
know the diode on or off.
Right.
The difference will be 0.7 or higher, diode on. If less, diode off.
Right.
That's the basic definition of the
Exactly.
diode.
Of the diode. Yeah. Okay. Thank you.
Mhm. Okay, now, next example number 3. Okay. Input 5 volt here, positive, and you get another one, 8 volt. Calculate given. VD equal 0.7 volt that they given to you. Diode on or off?
It's off.
It's off.
On.
It's off because 8 volts is higher than 5 volts.
Perfect. Now, before you want to say diode on or off, you need to know. Again, I try again. That's A. That's C. Voltage here. Okay. We call a diode voltage equal VA minus VC. Before you say the diode on or diode off, you need to know VA and VC. That means you get a A here, you get a C here. Okay. How do we know VA? How do we know VA?
5 volts.
How come you know 5 volt?
Because it right there, that's
No. Have to be more
specific.
You have to take out the diode.
perfect. That
Okay, so
is very good.
excellent answer. Who
Yeah,
said that?
that means you're supposed to be
Take out diode.
no diode.
No diode.
That means open.
That's right.
So the 5 volt here is supposed to be 5 volt here. Okay?
Mm,
And now when you get a diode, you get a 5 volt here and 8 volt here. So 5 volt cannot greater than 8 volt, right?
right.
That's why you say diode
Off.
off. Current I low here. What I equal?
0.
0. The thing is diode off, they will be out. Open.
Yep. No current flowing.
Okay. Next. Diode on or off.
On.
On or off.
On.
On. The reason is you get a power supply minus 100 volt. That means this side minus the other side here, 0 volt. So 0 volt higher than minus 100 volt, right?
Mm-hmm.
So the diode will be on. That's what they said. Diode is forward bias. On means forward bias. Off means reverse bias. That is just for the diode. Okay. Okay. Now, for the diode, you understand if they on, that means the VD have to be greater than 0.7 volt. Okay. We can say if VD diode on, for silicon diode, and also VD greater than equal 0.3 volt, diode on. Okay. For the germanium diode, basically depend on what type they build the diode. They can using silicon or germanium. However, we only deal with the silicon diode. Okay. Now, next one, Zener diode. For the Zener diode, this is a symbol. Minor difference with the normally diode. And one side anode, one side cathode. Same thing. A major application for Zener diode is as a type of voltage regulator for providing stable reference voltage in power supply, a voltmeter, or other instrument. Now I will be telling you why they need this diode. The thing in this diode will try to get a certain voltage you want. For digital circuitry, they need only power supply 5 volt, cannot be higher. Higher than 5 volt, they will cook the IC. IC will be burned. So that's why we're talking about Zener. They're talking about breakdown diode. when you go to buy the Zener diode, they will be asking you, what Zener voltage you want? And you have to say, okay, I want 5 volt or 12 volt or whatever voltage. You must get that voltage so they can sell it for you. Okay? The thing is when the voltage on the diode, for example, in the diode 5 volt, if higher than 5 volt, they cut it down to 5 volt. Okay? That is the purpose for the Zener. And now also, Zener can be working normal. Okay, if Zener like a normal and you get a positive, you get a negative, and 0.7 volt like the diode we just learned. Okay, if you get questions, they let me know. Now, for this circuitry, you get a Zener here. And a Zener voltage 10 volt. Okay. The thing is when you buy it, you say, okay, I want to buy a Zener 10 volt, and they give it to you. Okay. Let's see what happened in the example. Start without Zener. Okay. Same thing, like we just working on a diode. I want to know V out. If I want to
Same thing
know
you've
V
been
out,
doing all the time.
what?
The same thing you've been doing all the time. Take the diode out and then
Exactly.
look at the output and you'll see 20 volts.
Perfect. Yeah. You know, in order to know V out, we suppose no diode here. No diode here. Then no current flow. You get 20 volt. Then at the output here, you get 20 volt. Again, make sure you have to follow it, understand. If when you get 20 volt here, Zener diode only 10 volt. So automatically they not 20. They cut it down. They will be 10 volt.
The Zener diode go into breakdown.
Yeah. They break it down. Okay. For the circuit so given VG, okay, 10 volt. What is V out? If V in equal 20 volt, the answer will be 20 volt higher than breakdown 10 volt. So V out will be
10 volt.
10 volt. Okay. What is the current flow through 220 ohm? What current flow through here? I.
45 milliamps, 45.45.
Okay, so I will be 20 minus 10 divide. Okay, that means the difference between 20 volt and 10 volt. Okay, any question up to this point? Okay, if it no, go to next one. If we in 5 volt, what we out?
5.
5 volt. That means we out equal 5 volt. Zener not breakdown, correct?
And Mr. Pham, is that 5 or -5? You
Why?
got V,
How come you get negative?
yeah, V, you got Vn equal -5.
Positive, not negative.
No, I'm
Oh,
saying you got
negative. Sorry.
Vn is negative.
Yeah, minus 5.
So then V out would be -5.
Yeah,
VD equal V8 minus VC equal 0 minus -5 equals 5 volts.
no, what you mean 5? Now, we can that one, right?
I'm saying it's minus 5 equals 5 volts
How come you get minus? Hold on.
because
If
VA,
V in now will be negative, positive, 5. Okay,
So when you take the diode out, it'll be -5.
exactly. If no zener, okay, and they're telling you -5, so here will be -5. So that's why VL equal -5. Zener not break down, look like they will be like a normally diode. Just normal. Not
Mr. Pham, I missed that. So you said that the Zener voltage won't make any difference here. We will say that V out is -5 because it is not in breakdown, correct?
yeah, they not break down. Look like the zener not there. Zener either they break down, right? Or they not break down. And if they not break down, they just like a normal diode. So now we know zener is 10 volt and not a -5. Okay?
The anode is +10 and the cathode is -5, and +10 is higher than -5. So then it operates like a normal diode in forward bias.
Exactly. That means they not break down. However, zener look like normal. this normal diode. Okay. What is the current through 220 ohm resistor? If you get a -5 here, then the diode now will be look like normal. When the diode look like normal, what the voltage V out?
0.
They look like a normal. Okay. Then they will be VD. Let's see. Diode working. Normal. Okay. So normal, that means you get anode 0 volt and the cathode -5. Okay. Then diode on or off?
It's on.
On.
Yeah.
Okay. Diode on. They're telling you VD 0.7 volt. So diode on. Now look like negative here, positive here. Minus plus 0.7 volt. Okay. Then the answer will be, what is the current through 220? Okay. So the I equal, okay, minus 5 volt. Minus to minus 0.7. You get minus 4.3. Okay. So you can get a minus here 4.3. And the current, now they go this way. I. So I will be minus 4.3 minus to minus 5 divide 220. Okay. So minus plus 5. 5 minus 4.3. 0 point. That's how solving that problem. Okay, now use telling me for this problem here. Okay. First thing, for the circuit shown for no load IL. That means right now we're working without IL. The question is, they want to know IL. ILIG. If you don't have a IL, so IL will be 0, right?
Yep.
Okay?
There's no load.
The thing in all resistor load. That means open here, right? Open at VO. Open here. So current not coming out. So IL equals 0. Now, when you're looking into the circuitry, what happened to Zener diode? They on or they not working, they not break down, or they just like normal. You have to come up with that answer. They break down, or they not break down, or they just working like normal diode. Which one?
You do it like we've been doing before. In this particular problem, you said that there's no load. So we treat it like the 490 resistor is not there. So just forget about it like it's not there. Then the next thing you do is you pull the diode out and you'll see that VN is 24 volts. So where V out would be, it'll be 24 volts there.
Okay, correct. That means suppose no diode, Zener diode. Then the V here,
24.
24. Okay? Now, if that 24, what the VG? That means the breakdown.
Breakdown is 12 volts.
12 volt. Okay? 24 higher than 12 volt.
Right.
So
So
Zener will be
breakdown.
breakdown.
Mhm.
They break down. That means the voltage here now will be
12 volts.
12 volt. The thing is Zener breakdown equal 12. Any voltage higher than 12 volt, Zener breakdown. Okay? So that's why you get 12. And then they want the Zener IG. So easy. IT or IG the same. Equal 24
Minus 12.
Minus 12.
minus 12
All over 470.
470.
470. Okay? That means IG 12 divide, let's see.
25.5 milliamps.
Oh, okay. 12 divide 0.47. 25.5 milliamp, correct?
Yep.
Milliamp. What V out?
Well,
Okay.
Yep. 12.
Okay. Now go to number D. V out with the load. So now they add in the load. Okay. They adding the load. So before you want to do anything, now they add 490 ohm. So what happened to the zener now? Again, the key point is you must prove the zener will be breakdown or working normal. In order to know, and now you need to know what V out without the zener. V out without zener. So what V out equal? How? How do I calculate V out? Look like we don't have a zener there.
R plus RL divided by 24 divided by R plus RL.
24. Who know how to get V out?
R plus RL divided by 24.
Okay.
That's I out.
Look like he get that. You have to using 24 time RL divide R. Voltage divider. Okay. Let's see. What you get? That means 24 times 490
12.25.
divide
I'll be right back.
470 plus 490. What you get?
$12.25.
Look like I get 12.25.
That's what I got too.
Okay, perfect. So V out with the load equal 12.25. Okay, now they want IL. IL equal V out divide IL. IG equal V out. Okay, divide okay, I total. That means I total go this way. One go here. One go here. And now you already get IL. So if you get the I total, then you can minus UIL. You can get IG. Okay. IG. I total minus IL. Okay. Equal. Okay. I total. Okay. Let's see. You get the V out 1225. Okay. 22. 24 minus 12.25 equal. Okay.
I total minus IL.
Yeah, but the thing is right now I calculate I total.
Oh, I thought we already did that. No? Huh. Okay.
Yeah, we're not. So 24 minus 12.25 VL. Okay.
Mm-hmm.
Divide 470. .47 and minus 25. No,
No, it's I total is 24 minus 12 divided by 470 equal 25.5 milliamps.
okay. So the signal will be breakdown, right? VL equal 12 volt. Okay.
Mm-hmm.
You take 24 minus 12.
Mm-hmm.
12
Mm-hmm.
divide 470.
Mm-hmm.
That means I total.
Mm-hmm.
Okay.
25.5 milliamps.
You get 25.5, right?
Uh-huh.
Okay. Correct. 25.5. Okay. And now you get the current go into, let's see, IL,
Mm-hmm. So IT minus IL.
IT minus IL.
So 25.5 milliamps minus 24.49 milliamps
Okay.
is
24.
point oh one.
Is it 01?
Is it 0.01?
The thing is you get a 12 volt, right? 12
Mm-hmm.
by
Mm-hmm.
490.
Mm-hmm. Mm. Interesting. Okay. 24.49. Yeah. Hmm.
24.5.
Oh, point 0.5. Yeah. 24.49 is what I got, but I guess rounded up 5.
1 milliamp.
Mm-hmm.
Okay.
Mm.
Hey, man. What thing? Okay, this just for you to see that. Okay. You can see, man. Sideways here. Zero breakdown, 3 volt. Okay. So when you see the output equal 3 volt, that means zero breakdown. For positive, 5 volt, 5 volt higher than 3 volt, they break down. So VG 3 volt. And the negative here, okay, zero not breakdown. Okay. That means you get a negative on this side, 0 on the other side. Zero work normal. That one, normal. Okay, so that's why normal, that means you get 0.7. Okay, and this side will be negative, this side will be positive. That's why you get minus 0.7. Okay, and the other one will be the same. One they break down, one they working normal. And now they get both, and the output will be look like, okay, either vaginal blood or minus vaginal minus. That means which one will be on normal, which one will be breakdown. Okay, and also this given to you, you get a sine wave 10 volt minus 10 volt, and the output will be, okay, which gene be breakdown, okay, and which gene working normal. They draw the Vout wave for above circuitry. Then they become on that one, okay. If we cannot really understand it, then when you're doing MC7, draw this circuitry, you run it, they coming out exactly the same thing. Okay? We don't want to spend too much time on this thing. Nothing to do with us. Okay, light emitting LED. That means the light turn on, turn off. Okay, by the diode. And this is a 7 segment. Okay, so they can turn on, turn off to display any number. Okay, you want it. Or any letter, A or B or C. Like that one. A will be look like. Okay. That will be A. Okay. That means they try to display for the human. Understand? Okay. That's what we call LED. Now, halfway rectify. That means that is the rectifier. Input, you get a sine wave. Okay, sorry.
Hmm?
Hello. Tôi đang dạy học. Tôi đang dạy học. Okay, so this is a sine wave, and they go to the rectifier. Okay, they want to delete negative and only positive. Okay, that halfway, that means they just only let a half of the sine wave coming out. They take out the negative part. And now, halfway rectifier. Okay, so basically, you get a signal, full wave, sine wave. When they go into the halfway here, they get only positive. And then they go to the filter. Okay, and now this is zero right here, and basically that's a DC voltage, and at the top they get a ripple.
Yep.
That is like the noise.
Yep.
And when they go to the regulator, they get DC, no noise. That is the purpose for the rectifier. And the filter basically later on they will be just capacitor. Okay, try to short that ripple to the round. So that's why you can get a DC. Okay, so halfway rectified. Okay, they given you the output VDC. And now another circuitry. Let's see, halfway rectified. For this circuitry, you get sine wave applied to diode. Okay, and basically positive turn on the diode, and diode will be get that positive. However, when you go to negative, diode will be off, so will be no more signal. And they repeat again. That's what they call a half-wave rectifier. F in output, F input, frequency out and in, same thing. And second approximation, VP out equal VP in minus 0.7. Why have to minus 0.7? The thing is, when the positive apply, then the diode here will be on. On will be substituted by the battery. .7 volt, positive, negative. So that's why VP out have to be VP in minus 0.7. The thing is, diode will be on. Transformer. This is a transformer. Transform 1 voltage. Where? To the other. Okay. Primary voltage VP. And the secondary voltage we call VS. That's a primary. That's a secondary. NP, number of turn in the primary. And S, number of turn of secondary. That's why talking here. NP and S. NP and S equal VP over VS. Then VS will be equal. If NS greater than NP, step up transformer. NS less than NP, step it down. That means sometimes you get given you example. You get 240 volts. And we don't want to using 240. We're using 120.
20.
So that's why they need a transformer.
Yep.
Okay? So they can divide the voltage by following the formula here. Okay? Now, halfway rectified. The peak secondary voltage VP. That is, man,
Hmm.
Page 156, the transformer 2 to 1. Okay, and this is the secondary IL. The peak secondary voltage VP. So they want to know what the V peak of the secondary. They given you the calculation. V primary equal V peak in equal to 56 here. Then the VP second equal V peak in time 1 divide 2. You get 78. Okay. That means right here 78. Okay. The rectified peak output VP. Okay. And now they really want to know what we hear. So diode will be on. So you get plus 0.7 minus. So the output have to be subtract the minus 0.7. That's why you get 7.3. And the frequency, okay, if input frequency 1 kilohertz and the output frequency same frequency, okay. Only thing we're adding here is the transformer. And now full way rectified. You can see the circuitry. That one is halfway. Okay. This is halfway here. Only positive. Let's go. And now they want both. That's why they want the input here. Positive, you get positive. A negative, also they get a positive. That's what they call full way. They rectify on positive and negative. And now this is a transformer. And they connect in the middle here to the ground. So this will be a center tap transformer. Okay, center tap transformer. That means they separate, okay, one going up here, one going down here. Okay, the DC average, VDC, equal to time V peak divide 6.284. Okay, F out equal to time F in. That means output frequency equal double input frequency. Ideal diode 0. Practical diode 0.7. And VP out output peak equal VP in minus 0.7. Okay, I guarantee when you're working, you will be draw this circuitry in the MSIM7. When you run simulation, they can give you exactly the output will be look like. Okay, and this is a center tap full way. rectify. Okay? They're telling you input is a full way here. Then the output secondary, V secondary divide 2. That means you get two signals, opposite. This going up, this going down. Then they connect to diode 1, diode 2. That's a center tap full way, rectified. And they given to you more detail. Okay? And output will be look like. Okay? We'll be telling you which diode on, which diode off. And that is finally telling you how output will be look like. Okay? And output will be V peak, primary divide to minus 0.7. Okay? That's just a formula. You need a time to go to the example. And now, instead, same full way rectify. Same thing like
Woo!
okay, center tap full way. Okay, this is a center tap full way using the transformer. This is the output. And now, same thing. They don't want to using transformer. They using only 4 diode. This is the input. And now the output rectify both. That's what they call a full way. They work in the same line, we just get it. However, this one really cheaper. Center tap transformer cost a lot of money. So that's why they don't want to using center tap transformer. They using the bridge rectifier. They working the same, but much cheaper. Okay, that will be explained more when we get the time. Later on, I will explain to you how they working, not how to understand. Okay? However, I want to get few minutes to talking to you about left volt. Okay? Okay. Now, I want to talk to you on that one. Let's see. Can you see the picture?
Not,
Diode?
we see our names all up on the screen.
Let's see. I say I did one. You see diode way?
It says yes. We see
Okay.
a circuit board
Okay. Now,
and a conductor.
when you do the left, that will be stuck with diode way, stepping zero regulation. Okay, again, I try to make sure you understand. You don't care about unit object, don't care fundamental. We care exercise 1, 2, 3, unit 10. That's only one we want. We don't want troubleshooting. Okay? That's what you have to understand. We don't want to waste the time to reading everything here. Take you 2 years, cannot get it done yet. Okay, and now they say, I go to here, they say, you need whatever, multimeter, scope, or whatever, okay? Diode were setting. In here, you can position.
If you're trying to show us a screen, what we're seeing is a picture of the circuit board. So if you're trying to show us a lab volt screen, we're not seeing that.
You see that?
We're
You
seeing a
get-
picture of a circuit board, the semiconductor circuit board.
No. Do you see the diode? Locate the diode way.
Yes.
You see that?
Circuit board.
Oh, you see the circuit board.
Yes.
Okay. They're telling me where am I? Let's see. Okay, you see locate the diode way, right?
Yes. Yes.
Okay. Okay, let's see.
Okay.
Okay,
It went away. Okay, now we see your blue screen.
okay,
Now it's back. Okay, now it's back.
okay. So locate diode way, right?
Yes.
Okay. This is the circuitry they want you to do the lab. And now this is the circuit board.
Perfect.
That's a circuit board. Okay? If you're looking into the circuit board, telling me which circuitry will we do?
Semiconductor devices.
You're looking on that. Read
Diode.
that
Yeah,
one.
it says
Tell me which one.
locate the diode wave shaping circuit block on
He's
the
asking.
semiconductor.
He's asking which circuit we're going to use. It's the diode wave shaping on the bottom right.
Right.
Right here, right?
Yeah.
Okay. You see, this is the circuitry you will be working on. Now, this is the circuitry they want to do.
Yep. They want you to build.
Telling me what's going on here.
Mm-hmm.
That means you have to build this circuitry like they want it here.
Exactly.
How?
Okay, you take jumpers and you create that circuit.
Now, right now, you need the either 2 pole on the wire to connect to the circuitry you want. You see, this is the generator, go to R1, right?
Yep.
Generator right here.
Mm-hmm.
They can go this way, or they can go this way.
Mm-hmm.
You need the connect right here,
Exactly.
okay? You adding the two pole in here, or the jumper connect here.
Mm-hmm.
So they will be go into here, okay? And
Mm-hmm.
go this way, okay? And go to R2 here, correct?
Yep.
That is the one I want to make sure you have to make the right connection before you want to do anything.
That's right.
That's a very important. Now they not connect the two pole for you, not connect. You have to know how to make a connection. Otherwise, anything will be wrong.
Yep.
Okay? Anything they telling you here, you already know. Okay, quickly I go. Okay. Now they want the circuitry will be look like. So the generator go to R1, right?
Yep.
That. And they go into here. And also they go to CR1. And now you need to adding another jumper here, correct?
Yep.
So they go here.
Yep. To the
Okay.
diode.
If you not connect right, anything will be wrong.
That's right.
So the thing I bring it up to make sure you understand is when they want you to do, they telling you the circuitry they want, and you're looking into the circuitry here and adding more wire connection to connect exactly what they want.
Yes. It's really important. That's for sure.
Very, very important. Okay. Now, take one tomorrow. You get the lecture for
Oscilloscope.
the level. What I want to for you, just ask the instructor. You want to know oscilloscope generator, how to set up whatever. That's the first step. The second one, we want to go into the level circuit and how to working like I just talked to you. Okay? Don't spend the time try to go again the lecture. We don't care about lecture. We don't have enough time. So we just now want to know. If I want to, they said, doing a diode wafer sampling, following the instruction.
In other words, what I think the main point here is, guys and gals, is you can read the lab volts. They're all uploaded on the website. You can read all of the lecture notes from the lab volt that you're working on at home. And then you can come into the lab and just do the exercises and the test. And you can really get a lot more done in the lab if you do it that way.
Perfect. That means you get a circuit board. You can copy. You get that one. Then by looking on that one, before you want to do, how do we connect the circuitry like they wanted? That means perfect to get any level done. Okay? Level they working, they create the program take too long to understand everything. We don't need it now. Okay? Basically, any calculation. I can get a simulation. I can get that. I don't care. Technician. I really care basically in general how the circuitry working. Okay? So that's why the reason sometimes I still go to the class, the thing I want to see how the instructor can help your guy to do. Okay? If you get as much as you can to get the left one done, you can take vacation. No big deal. Okay? The thing is, this is a technical program. We don't care you come into the class and you get nothing to be done. You still in the Tech 1 forever. You cannot get a certificate to go to Tech 2. Okay, anyway, I will be stop it at this time. Okay, I want to know. Okay, any question, anything. Hopefully, I will be see your guy on Monday. Okay, if you
Okay.
don't know anything, I will help you. Like you want to using the scope, I get a program already in the computer. Click on that, they telling you what to do. Okay. However, tomorrow you will be learn more. Any
Hey, Mr.
question?
Pham, are you gonna do a Tech 2 on Zoom tomorrow?
Yeah. Tech you will be Zoom tomorrow at 5. I don't want it. I work too much. However, you have to take you. I have to do it. And also, now I spend, on Monday, spend time try to get the Zoom 240. About 8 computers must be on. So, student Tech 2 can working on Zoom 240. Any question? Anything? No? Okay, if not, good night.
Good night.
Fun.
Thank you.
Thank you,
Bye.
Mr. Pham.
Yeah, we'll see you.
See you Monday. Have a good
Thank you.
weekend.
Bye bye.
Bye. Thank you.
Thank you. Bye bye.
Boop, 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 boop.